Welcome to the HiRSE Seminar Series on Research Software Engineering in Helmholtz and beyond.
Right. Hi, everybody. Thank you, Claire, for the introduction and the invitation to give a talk today to this group. I hope I can initiate some new thoughts on your end and share some interesting stories around reproducible research and how I think it can benefit from our research software engineering expertise. So the slides are also online. If I quickly copy the link to the chat and don't type down the DOI, that one doesn't work just yet. But I put the link in the chat if you want to follow along at your own pace. So code execution during peer review, CODECHECK and RSE reviewers. Let's start first by reminding ourselves of what closed and irreproducible research means, which is the basic challenge that we try to solve with CODECHECK and related initiatives. First, closed and irreproducible research, it cannot be fully understood or verified. It obstructs effective reuse and extension, therefore it's not sustainable. It prevents usage in education and citizen science, and thereby it slows innovation because, well, things are closed and we are going to repeat ourselves again and again if we want to advance our research. So no talk about reproducible research is complete without mentioning Kleebout's claim. So I hope at least some of you haven't heard this yet. If you've ever listened to a talk by me, you've seen this before. So the Kleebout's claim is an article about computational science in a scientific publication is not the scholarship itself. It is merely advertising of the scholarship. The actual scholarship is the complete software development environment and the complete set of instructions which generated the figures. So even when we know that, we just have the goalpost where we want to be. We want to share everything. And that's why I want to first spend a few minutes on how can we effectively share our research and what is so challenging about that. Some of you might be aware of this meme that is already probably quite old. And this is the question of how to draw an O. And it starts with these very easy first steps. So you just draw two circles, sort of to shape the body and the head. So that's the first step. And the second step is finish the O, draw the rest. And that's, of course, not helpful. But this is sort of the level of support that is available for sharing research, because our individual research environments are, by definition, relatively unique. So the moment that I do interesting new research, I might develop my own tools to do just that. And there is no simple boilerplate that we can share with each other and that we can follow, because the uniqueness of the researcher's workflow make it really hard to abstract or to find a common ground that is really the same for everybody, and that would make it easier for us to explain how to effectively share your research. So another situation might be here where somebody extends this and adds a few more steps on drawing a horse, and I find this equally funny. Then we just add a few details in the end. And this is probably where we can get with sharing computational research is I can tell you the first few steps that you can take, but to really effectively share your research, you need to practice doing it, because there's no one solution to achieve it. And there's many tools around. I'll mention a few of them later. But really, the practice of doing it is the most important thing in my view. So if I only would have to boil it down to one thing, I always tell people that they should have a README and everything else is details. So try to communicate your research in a way that you can give a list of steps to another human that they can follow. And if they follow these steps, they are getting close to the computational environment that you have, and your data and your code and as close as possible, and that will give them an opportunity to follow your footsteps and reproduce your work. And in all this, it's really hard to document for somebody else. So my recommendation is always document for yourself first, and then hope that somebody asks you, they don't understand what you did, and then you can provide a lot more extensive information. So how can we then manage that this README that you've created actually is useful? To ensure that, I would recommend that you have a colleague run your workflow before you submit it. That really is, I think, one of the crucial steps to develop a practice of being able to sharing research openly and reproducibly. You can return the favor then later, and that will also help you to develop your skills in this area. And of course, you have to publish your code, your data, and properly cite data and software that you use. But I think these are things that are relatively clear for the audience here if you are interested in research software and have some skills in this context. But these things are much harder, in my experience, for people who don't have such a strong computer science or computational background, but are really domain scientists, and they are required to share their research more openly. So if you want to learn more about reproducible research, take a look at the Turing Way, and that's where everything that you need to know exists or is linked with beautiful graphics to make it enjoyable. So let's take a quick excursion to start the connection between reproducible research and research software engineering. So what really helped me to understand the challenge around sharing computational research is that we have a traditional model of scientists of a skill set. And this is, I think, from it's a concept of so-called T-shaped skills that you have, that maybe your employer writes down if somebody wants to hire a new person. You can look at the concept of T-shaped skills as a metaphor that's used in job recruitment to describe the abilities of a person in the workforce. So you have the vertical, deep knowledge and expertise within a single field. But to be effective in your work, you also need broad knowledge across disciplines. So you are able to collaborate with other experts and apply knowledge from outside your field or transfer it to outside your field. But today in research, when we use computers, we are faced with the challenge that we need pie-shaped skills. And this is unfortunately not the pie, but if I mention pie, I should show you a pie. But the Greek, the letter of the Greek alphabet pi in capital. That means that we don't only have deep knowledge in our field and broad knowledge, but we also have deep knowledge and need to have a deep knowledge in computers and methods skills. And this makes it really challenging to share research reproducibly. It makes it challenging to develop new research methods. And that's, of course, why research software engineering as a field or as a community exists. But I want you to keep this in the back of your mind, that this challenge that we need different skills to effectively conduct and communicate research really is something that is not considered during today's practices of scholarly communication. So how does one researcher share information with another? And as part of that scholarly communication, the practice of peer review, which I'll go into now. So how do we think we need to change the way that we share research? We came up with the concept of a code check. And so back to the situation that how we work today is that we in your lab or in your research institute, you have data and code, and you run different models and find results. You might be using notebooks in paper form or computational notebooks. You have all these things, but traditionally, and in the majority, what you're sharing is still what we call a paper. which often is actually a PDF or an HTML document. So while we share this, we sort of hinder reuse and transparency and collaboration, and we need to break out of that. But that means that we also need to break out of the habit of writing papers as the main means of communication, and we also need to face the challenge that we need to reconsider how we give credit in academia. And that is, for me, an interesting aspect in this also for RSEs, as us RSEs often challenged with getting credit for our work in an academic environment. And we are, I would say, very far from being able to build a career just around publishing software in academia. So we need to, I think, it's hard to talk about improving peer review and computational reproducibility without at least having in mind that there are these huge challenges for academia around researcher evaluation and giving credit for research that are really connected to everything we do, and thereby also need to be considered when we think how we can reform or improve code execution during peer review. So concrete recommendation for me is that beyond, if you are saying, yes, I have a README file now, but I would like to have a little bit more help, is that you can start and create what many people call research compendia, which means that you effectively use a packaging mechanism, for example, from your programming language that you use. So if you are using mainly R in your research, you might create an R package that helps you to give some structure to your code and data. And there are also different templates around for research compendia. And then you can use this as a package for really all the building blocks of your research. And there's a bunch of papers around that describe how you can create such a research compendium and how it also could be a successor of the traditional paper that we publish today, or the paper is a part of this research compendium only. And then sort of the paper is the textual entry point to the research compendium, but there should be different ones, different additional entry points, such as a makefile to run the code, etc. So the question now is, if we imagine a world where we are not just putting out papers like crazy, but instead share research compendia that have instructions that are understandable by a human, who now looks into this package? And I think you could be that one. The RSEs, I think, have an excellent matching skill set to help improving peer review by helping with the code execution and code evaluation. And this, for me, is related to a topic that is probably familiar with most RSEs, and that we need here some degree of professionalization. And one image that always resonated well with me is the idea of cooking, because everybody knows, well, not maybe cooking, but let's just say prepare food for you to eat. Everybody is able to prepare food, right? We can go to the supermarket and buy something ready-made. We might grow our own food in our garden. So there's many different levels of doing this. But just because everybody can prepare food so we're not starving doesn't mean that we're all cooks. And this kind of expertise and different expertises, remember the pie-shaped model, also means that in this image, if we want to get really great food, or if we want to serve hundreds of people at the same time, we let the professionals do that and not ourselves. And we call these professionals codecheckers in CODECHECK. So CODECHECK is based on 5 principles. We say codecheckers record, but don't investigate or fix. That means that codecheckers take your README, run through the steps, and when I'm stuck, Either the problem is so trivial that I can fix it, I might even send you a pull request, or more oftenly, I put the ball back in your field and ask you to help me out. That means that a very important aspect is the communication between me as a code checker and you as an author or creator of a piece of research. And we really need this communication. In our view, it's really hard to combine a code execution with a fully anonymized peer review. This is also a topic where we are or repeatedly facing challenges in the infrastructure that we use for scholarly communication. Just as a concrete example, none of the existing scholarly or the existing peer review platforms, be they open or be they commercial professional systems that big publishers use, supports that you have different means of communications between authors and reviewers. So either the review is fully open or it's fully closed, and you cannot mix and match, or you cannot have an anonymous chat or things like that. So it's really astonishing how infrastructure can limit our abilities to come up with innovative or just useful ways to conduct peer review and publication of papers. Then third principle is that credit is given to codecheckers, and we also want here reviewer credit. So we're not just saying there should be a public record, but we think this kind of work deserves the same recognition as a reviewer does. And that means that, the codechecker is part of the academic community and not just somebody who also does, somebody who does a code check, but it's not really as important as what the regular reviewer does. No, we think those things stand on the same level. This is related to principle 1, but we want to stress that principle 4 is workflows must be auditable. So we see the responsibility with the author to prepare something that we can check. And even though there is back and forth, there is limits in what we ask code checkers to do. The important thing about we are asking to record is also that we are not trying to check if something is correct. So we basically say we have an independent execution of a workflow, one similar to peer review. So in peer review, you as a reviewer, you get a document, you read it, you write a report about it, and then you either say, yeah, looks good to me, or no, doesn't look good, or yeah, maybe with some revisions, this is good enough to publish. So we put a lot of trust in that person, and we are doing the same with the code checker. The code checker gets all the information, writes a report, and then says, yeah, this was reproducible for me, or no, this was not reproducible. So we also put the trust in that person. And fifth principle is said that we are open by default. So we enforce, or we encourage that everything is shared openly, though we are accepting that there might be limitations to this. One common example is high performance computing, where not every code checker has access to that infrastructure. It might also not be fully open. There might also be a couple of proprietary libraries. But if we find one person that has access to the same resources as the author, and that person writes the report and gives a thumbs up, that is good enough for us. We're not dogmatic here, but want to be as open as possible. And we also say this is transitional by disposition. So if somebody says, well, this is just peer review, and we just call this peer review, and our peer reviewers execute the code and everything, that's fine by us. But we think that because of the challenges of the pie-shaped skill set, introducing this extra role of code checker is tremendously helpful in improving the situation. So if you want to learn more about CodeCheck, there's a fun video and a paper for you to read as well. So we've thought a lot about the different ways you could do this kind of CodeCheck. You can do it early in submission, sort of to filter out the noise and find good articles only. You could do it in private to open, so we prefer open, obviously. But you could also do it post-publication, just as an independent paper, and you could use it with different strengths, so to speak. So you can either say, this is a prerequisite, every paper has to do it, or this is something that is a bonus. And in terms of the different roles, just want to re-stress that we think RSEs can play an important role here because of their skill set. But also other career researchers could be a useful resource here. So if you are actually an academic and you're publishing papers and you're reviewing papers, you know that it's really hard to find reviewers these days because everybody is overworked, and reviewers are a scarce resource because, well, they're unpaid, and more of them, which I welcome, are quite critical for who they review, and ideally prefer, you know, open venues that are scholarly led instead of commercial publishers. Yeah, but in this system where reviewers are a scarce resource, we think that also having this extra role can relax the situation a little bit and make research communication a bit more effective. So let me talk for a couple of minutes about one instantiation, you can say, of CODECHECK, and that is the Reproducible Agile initiative. So in Reproducible Agile, we've started a couple of workshops in reproducibility and introduced the topic to the community because we realized that the papers that were published at Agile, which is a community organized conference by the Association of Geographic Information Labs in Europe. So it's geographic information science, different laboratories, they run a conference. And we realized that all these papers published there are not reproducible. It was really a bad situation. We assessed the awardees the nominees for the Best Papers Awards for the 7 or 8 years, I think, and none of the links to data or code worked if they were there at all. So it was really a bad state of reproducibility. But luckily, we got some institutional support, and we were able to create guidelines for writing reproducible papers, and then started doing reproducibility reviews because, you know, it was developed in parallel with CODECHECK, but we effectively started doing CODECHECKs in 2020 for the first time, and we are still doing that. So there now is a reproducibility chair and a reproducibility committee who take a look at the accepted full papers. Just a few words about these reproducible paper guidelines. So we decided to come up with community-specific guidelines to also handle maybe things that are quite typical in our discipline, but also to make clear that this is something that is should work for our community. So the basic idea is that we want transparency, and we're not enforcing openness completely because we acknowledge that there might be good reasons because you cannot share, for example, sensitive data. So we also want to promote and not exclude people. So basically to slowly shift how the community works. And that's why the only mandatory requirement is that you have a so-called data and software availability section where you write down data and software that you use and where it is available. And if it's not available, you do write that down. So the review process, as already said, we are reviewing accepted full papers after the accept-reject decisions. The peer review here is that the author is the reviewer is anonymous. No, sorry, it's fully anonymous. And we decided, therefore, also because of the resources that we have, to do the review after the peer review is completed. So we have a smaller data set of a smaller set of papers to reproduce. And also because the authors already know that they are accepted, we can start talking to them directly and don't need to go through any anonymization channels. And here on the right-hand side, you see how that looks like. These papers then get a badge on the proceedings page. or at the bottom of the first page of the paper. And this, if you click on that, it takes you to a reproducibility report, which, just to give you a quick impression, looks like this. We have all the citation information in the beginning, and then you basically have short bits of texts saying like, I followed these instructions, I did that, I had to install that software, these kind of problems that you might face. And then you add in the figures and results, how you created them. And if these are close enough to what the author did, we basically say this is a successful reproduction. But this reproduction can also be partial. So we are happy if there are parts of the workflow might not be reproducible. And we document that. So again, we're recording, but we're not fixing things. And this is then published and referenced from the paper. What is nice, of course, with this, because Agile doesn't give reviewer credit formally yet. How could you do that? You could, for example, connect the published papers with your ORCID profile, and there, from the publisher, get the official information that you've published a paper or you've reviewed a paper for them. So therefore, the only way we have right now to give credit is to publish the reproducibility report in an open repository, give it a DOI. But that's already quite cool, because you then get, for example, these reports are then picked up by ORCID and other platforms. So you can find these, add these to your academic profile. Just a quick look back. So we don't know how many papers were reproducible before we started, of course. We have the feeling that reproducibility was really, really low, and we did some research on that. But in the first three years, we basically went from 6 papers in the first year, 9 in the second, and we now, last year, the full reproducibility review that was completed, we had 72% of all accepted full papers successfully reproduced, which I think is a great success for this community. So how can we now get from what we did at Agile and how we design CODECHECK to really get introduce or reintroduce code execution into peer review and all the different disciplines? So I think there is a recipe here that could be reused. And I want to highlight a few points why I think this is transferable and what really the benefits are, and to reiterate a bit on that. First, I've mentioned that before, having a README, reproducing other people's workflows, this, in our experience, is really comparable to a craft. I can't give you a perfect checklist. I can't teach you how to reproduce papers once. You have to learn it by doing it yourself and by repeatedly doing it. And we are thinking about mentoring schemes where we have a senior code checker working together with a junior code checker to sort of give the knowledge from one person to another. But we've so far failed, partly maybe because we don't have the time to sort of create a set of guidelines for reproducing somebody else's work that is so complete that it will always work. So really, we don't want to play catch up with what researchers do, but we want to try to communicate or try to share practices and habits and approaches to become a more senior and experienced code checker. So it's, of course, also about helping other people and explaining things and creating a culture that is that values code and values code execution as part of a review process. Then I think this human-centered process that CODECHECK is, right? So we set things up in a way that a human follows instructions from another human, and they can talk to each other and they can collaborate to make things work. That helps us to handle the variety of research workflows that exist today. So this is a reiteration of the points I mentioned on the principles of CODECHECK. And So the code checker stops when they are confident, and then they give their thumbs up. Of course, we somehow transfer the challenge now from finding a reviewer to finding a matching code checker. But I think we have a bit more flexibility here to get there. Right. Then we have a communicative focus. So we're not saying you have to use technology A, you have to use reproducibility platform B, but it's something where really a human is the mediator and sort of, or the connecting part. And we are therefore hopefully also avoiding to play catch with innovation and technology, or not giving challenges to researchers because they might not have access to that technology if they want to participate still in this process. So we are trying to not to limit researcher freedom. And with that, and that's related to the big idea of the craft, we think that over time you can develop a shared practice, sort of build a community of practice. One point here is, of course, also that what reproducibility really means. I gave you one very broad definition, but what it means for your community and for your specific discipline might vary from what I think how reproducible is close enough to the original. Also, this communication, in our experience, really helps to change the attitudes and the willingness to be open. Case in point, again, a story that I've repeatedly faced is that I get a workflow, which is a bunch of a bunch of data files, a bunch of scripts, and a README that's just the default README on GitLab or GitHub with a couple of placeholder texts. And of course, I cannot do anything with that. I can run the script file, but then the paths are fixed and then everything breaks again. So I write back to the author and say, well, I don't know how to start. And then 24 hours later, I get this huge README with all the steps well-defined, and I can really work through that, and we go some back and forth. I help to improve how the workflow looks like, and afterwards we have a reproducible pipeline, and that is transparent and open. And I've learned something about a new tool, and the author is now more willing to share and more willing to prepare their work in a way such as a research compendium, so that maybe next time and the next code checker or the next researcher who is interested in that work doesn't have to go through the same process or ask for it. So, but in our experience, just somebody asking for this kind of information makes a huge difference in terms of what is provided. So tools and infrastructure, I already mentioned that there's many different tools. They certainly help us to code check faster. Examples are computational notebooks. There's things like Binder to run notebooks in a browser and an open infrastructure. There's tools to work with more open methodologies, but these are all making things faster and easier and not really solving the problem in the big picture. So I'll skip that. So who are other candidates to apply for CodeCheck? So I would like you now to take 5 seconds and think about the one journal that you really like and tell me about it, because I think we can put it on the list of being a candidate for having a CodeCheck-like procedure to recognize that we need to think about code and data when we share research. So what can you do today? I'll make this brief, but maybe some of these bullet points strike something for you for the discussion. When you share your research, try to do it as reproducibly as possible. And if you are ever an evaluator in some form, be demanding and ask for code and data, and try to find the time to actually do a code check. Maybe with some of the arguments that you learned today, you can initiate a discourse on code execution. If you're an author, a reviewer, or an editor, we've had the cases where authors said, it's really cool. I want to do a code check, and I've submitted to this journal. And I wrote to the handling editor, and sort of we got into a conversation, and about code checking, and eventually the paper and the code check was published. And we are trying that as an entry point or as an in with journals to properly establish these such practices. That, of course, also means you're welcome to become a code checker. You can sign up on our website. But currently, you might have to wait, or ideally, you can help us to properly establish code check as steps of peer review with journals, because that's what we are working on now, finding journals and or conferences that want to implement our approach similarly to what the Agile community did for the Agile conference. What do you get from all this? Well, you get gratitude because you can help others. But more importantly, you also can give back to your community and help to spread practices. I know that RSEs often are very happy to educate others and educate researchers and spread their knowledge about computational methods. And this is a great way to do that as well. But also in the big picture, you get something out of that because you are becoming part of how academia, of the academic community built around journals. So ideally, you get recognition as a reviewer, and you get recognition in the academic community of your field by being a reviewer or an editor eventually. And fun fact is, you get to know all the package managers. You'll be able just to see a package manager configuration file, and you know the commands and to try to make things work. It's a nice challenge, and in my experience, it's always I always learn something from that. So you're also developing your own skills when you try to reproduce somebody else's work. Right. So to wrap up, you all know the phrase "better software, better research." So if I slightly extend that, I would say better checking of software by RSEs improves peer review to foster better research. So with that, I thank you and look forward to your questions.
Thank you for watching our seminar. Please check out the slides on Zenodo linked below, and see you next time.